All right. Hey, y'all. What's up? Okay, we're getting right back into it. Section 14.2 Homeostasis, specifically looking at our blood glucose. Now, when I say homeostasis, this is the maintenance of a constant internal environment, which means all of the internal conditions. Most of us automatically think of temperature, which is absolutely correct, but it's also blood pressure, the water concentration inside of our bodies, the glucose concentration. All of these must be kept within set limits to ensure that our metabolic reactions in our body cells can function and therefore ultimately we can survive. So, when we are talking about homeostasis, and specifically glucose, as well as really anything that homeostasis is that's occurring in our bodies, we have a very important mechanism that is a process known as negative feedback. So when your body is trying to keep everything in a set limit, so to speak, so it doesn't need to get too low, but it doesn't need to get too high, and there may be kind of some room for there to be wiggle room, so to speak, before everything's just gone haywire. We are going to use a process called negative feedback to balance things out. The way that I've always explained negative feedback to my kids to help you understand is if you've ever ridden on a seesaw in a playground. So remember, a seesaw is like a board. There's one of you on the end and one of you on the other, and you just go back and forth, right? In our bodies, for temperature control, blood pressure control, water concentration, glucose concentration, our bodies are constantly seeing what happens if it rises, we've got to bring it back down. Or if it gets too low, we've got to bring it back up. All of those responses inside of our body are controlled by that negative feedback, bringing up either the level of whatever we're working with up or bringing it down, okay? So like a seesaw, trying to balance it out. Now, when we look at negative feedback, kind of a neat little image here that you can see is the conditions in the body change from that set point. Here, change is detected. Corrective mechanisms are activated. So let's say a hormone is released from your gland, going to those target organs. The conditions return to the set point, and then that corrective mechanism, the hormone, the gland secreting it, is shut off until the next change occurs. Okay, so that's negative feedback. Then when we specifically look at glucose levels. All right, so in our bodies, very, very important that our glucose, which remember is a sugar, it's a carbohydrate, it's what we use for cellular respiration, so our cells have energy, is controlled by, of course, negative feedback, but involving two main hormones, insulin and glucagon. I'm fairly certain you've heard of insulin because some of us, unfortunately, don't produce it, and that's ultimately what leads to type 1 diabetes or even type 2 diabetes, which we'll talk about the difference here in just a second. But glucagon is probably a new one. Now, both of these are created in the pancreas. Insulin is produced when blood glucose rises, and we must have the liver stimulated to convert excess glucose into glycogen to be stored. So when you eat a really sugary meal filled with glucose, it enters into your body, goes through the digestive system, it's trying to be assimilated to where it's needed. When you have an overabundance of that glucose, your pancreas needs to secrete insulin, which will then stimulate the liver and muscle cells to absorb that glucose and convert it into glycogen, which is how we store glucose for our later use. All right. Now, the opposite is occurring if you have your blood sugar that is too low. So with insulin, blood sugar is way too high. We've got to bring it down. We've got to store that glucose as glycogen. With glucagon, this is when blood glucose falls, and we must stimulate our liver and muscle cells to change the glycogen to glucose so it can be released into the blood so we can function. So insulin means blood glucose levels way too high. We need to store some of that glucose, save it for later. Glucagon means glucose levels way too low. You have a drop in your blood sugar. We need that glycogen to be turned back into glucose and sent out into the body. Great way to remember it. Insulin, I need to take it in. I need to take the glucose in. Glucagon, glucose is gone. I need to put some out. It's gone. I need it. Okay, so that's how I kind of remember it. I hope that association helps you. And then finally, what we can talk about is diabetes, which is something most of you have probably heard of. You might even know somebody that struggles with diabetes. Type 1 diabetes is a condition where the blood glucose levels are not able to be regulated because the insulin secreting cells in your pancreas do not produce enough insulin or insulin at all. So that means you must have injectable insulin. Type 1 diabetes is one that you are typically born with. It's something that's inherited. So it's something that ultimately you don't necessarily control. Okay. So any type of anyone with diabetes would have symptoms of extreme thirst, weakness, tiredness, blurred vision, weight loss, and loss of consciousness in extreme cases. And you continually have to monitor your blood glucose levels. Luckily, with scientific advancements, there's been some really neat devices that are wearable for individuals, so they're not constantly having to poke their finger and draw blood and test it with strips and the little machine. It can be done as something that individuals wear, and it does it for them. But ultimately, they have to control their insulin levels with their diet, their exercise, and of course, injectable insulin when it's absolutely necessary. Now, on the difference of that, type 2 diabetes, same concept of your body's not able to regulate your insulin. However, the majority of people who have type 2 diabetes, it is something that you develop because of poor diet and poor exercise. So it can be controlled, yes, through injectable insulin, but it also can be helped or sometimes completely cured from you by changing your diet, changing your lifestyle, and getting in better shape. So just wanted to give you that tidbit in case I know we just covered type 1 diabetes, but a lot of people have questions about what's the difference. Exam tip, and then we'll wrap it up. The terms glucagon and glycogen are very often mixed up because they sound a lot alike. Glucagon is the hormone. Remember, that's when glucose is gone. It's glucagon. And glycogen is the polysaccharide that glucose is stored as. So glycogen is what we store in the liver and in our muscle cells for later use. All right. Good job. Go on over, head to your notes, move on to the CFU, and then the daily activities. Good job, guys. I'll see you when I see you.